Hello everyone, in this lecture I want to talk about foreign keys. Let's go back to our two tables. The first one is the students table that saves data about students with all the details, and the second one is the courses table that saves data about courses. Now suppose we want to store data about which student took which course. For example, we know that John Smith took the course OOP, and we know that John Smith also took the course database, DB. And we know that Sarah Berker took the course OOP. Where can we store this data? The first attempt is to try storing the data in the students table. For example, we enlarge the student table and edit the properties, the columns of the course. And for example, we can see that in the line of John Smith, we have the properties of the course John Smith took. And in the line of Sarah Barker, we have the additional properties of the course Sarah Barker took. But this is not a very good idea. Every student can appear only once in the table, so we won't be able to store several courses for each student. In this example, we already saw that in the previous slide, John Smith took the database course, but in this table, we cannot indicate this fact because John Smith appeared only once in the table. Another attempt is try storing the data in the courses table. For example, this is the courses table and we enlarge it by adding the properties, the columns of the students. And we can see that the course OOP was taken by John Smith with all its details. But this is obviously won't work. Each course can appear only once in the table, but each course has many students enrolled. In this example, we know that Sarah Barker also enrolled to the OOP course, but we cannot indicate this fact because the line of OOP appears only one in the table. So what is the solution? Let's define a third table. We will call it studied and it will store the data about which student studied which course. This is the table studied. You can see that the table consists of the elements of the students table and the elements of the courses table. Let's look in detail in this table. This table can capture all the data. You can know that there are no two rows that are entirely identical. One student can definitely take many courses. We can see that John Smith appears twice in this table, but since he took every time a different course, the line of John Smith is not entirely identical, so we can repeat it. One course can be studied by many students. You can see that the course OOP is taken by two students and the details of OOP appears twice, but in every time with a different student. So this table definitely can capture all the data we want about which student studied which course. Now let's talk about data duplications. Data duplications is a situation where we save one piece of data or one item of data in more than one place. Data duplication is prone to problems for several reasons. First of all, we store the same data items many times, so we use a lot of redundant storage space. When we dealing with a lot of data, this could be very problematic to the space of the database. But another problem is that we might create contradictions in the data, which means that we have two contradicting facts about the same data and we wouldn't be able to decide which of them is the true. For example, let's go back to our example and suppose the John Smith average had changed to 92, as it indicated in yellow in the students table. But now you can notice that we have to remember to change the average in every place it appears. In this example, we saw that the average property of John Smith is also duplicated in the studied table. And in this table, the average stayed as it was previous the change. So now, if we ask ourselves what is John's average, the answer, the very disastrous answer, is that we don't know. The data is contradicting because one table, the students table, said the John Smith average is 92 and the other table, the study table, says that the same John Smith has the average of 90.5 and we don't know which of them is the fact of the data. This situation is very dangerous to any database system. We have to be able to trust the data. The data must be reliable, and the opportunity of the data to contradict itself is very dangerous to the business we're running. So the solution is like that. We don't need in the study table to save again all the additional features of the student. We don't need to save the first name, last name, and the average because those fields are already known in the students table. And again, we don't have to save the course details, the course name and the credit points, because those details are saved in the courses table. So our studied table shrinks and becomes very small. It saves only two columns, the ID, which is the student ID, and the course number, which this student took. Those columns points to the primary keys in the student and courses tables. So we only have to store the primary keys of students and courses. Through those keys, we can obtain all necessary information without duplicating it. For example, we see in the first line in the studied table that the student, which is number 111, took the course which is number is 1234. If we want to know what is the name of this student, we just have to follow the students table, and there we have to find the 111 student, the student with the ID 111, and there we can find all the additional data needed to know about this student. And if we want to know what is this course 1234, we have to follow to the courses table, and there we can find the CNAM property, which is 1234, and then we can see that this course is OOP, which gives 6 credit points. The columns ID and CNAM in the table studied are called foreign keys. A foreign key is one or more columns in one table that is defined as a primary key in another table. You can see that the ID in the studied table is defined as primary key in the students table, and the CNAM in the studied table is defined as the primary key in the courses table. And what is the studied primary key? The student ID can repeat many times. As we can see here, the 111 ID repeats twice because it represents the same students that took two courses. And the CNAM, the course number, can also repeat because we can see that here the course 1234 was taken or was enrolled by two students. So every one of these properties or these columns can be by itself a primary key. But the combination of them both cannot repeat. So the primary key is a combination ID and CNAM, because the combination of 111, which represents a specific student, and 1234, which represents a specific course, cannot repeat itself twice because it isn't logical and it isn't reasonable. So this is the primary key of the studied table. So in this lecture, we saw a very powerful concept called the foreign key that allows us to capture additional information that's found in the connection between two or more tables in a way that we don't have to duplicate all the information that is already found in the original tables. We just have to duplicate the primary keys, and through the primary keys we always can go back to the original tables and achieve and obtain the rest of the information needed.